The local inspector's requirement for a number 8 conductor for bonding is excessive and not supported by the National Electrical Code. The National Electrical Code requires only a number 10 AWG copper conductor for bonding exposed metal parts of electrical equipment, regardless of the size or type of equipment as stated in NEC 250.104a. The wire size for the branch circuit conductor is determined based on the load and overcurrent protection of the circuit. A number 12 AWG copper conductor is sufficient for most hydromassage tubs. The bonding screw on a hydromassage tub motor is intended to be used for bonding exposed metal parts, such as the motor housing and pump body, to the electrical system. This bonding ensures that all accessible metal parts are at the same electrical potential, eliminating the risk of electric shock. The NEC does not specify a minimum wire size for bonding conductors. However, it is recommended to use a wire size that is equal to or larger than the branch circuit conductors. A number 10 AWG copper conductor is sufficient for the bonding screw on a motor, as it provides a low resistance path for current flow. The inspector's reasoning that the number 12 branch circuit conductor is not sufficient for bonding is incorrect. A bonding conductor does not need to carry any significant current, only provide a path for fault currents to flow. Using a number 8 conductor for bonding is unnecessary and could create issues with wire bending and termination. In conclusion, the local inspector's requirement for a number 8 bonding conductor is not supported by the National Electrical Code and is excessive. A number 10 AWG copper conductor is sufficient for bonding the exposed metal parts of the hydromassage tub motor and should be used instead. The purpose of bonding is to create a low impedance path for fault current to return to the source, which facilitates the operation of the overcurrent protective device, such as a circuit breaker or fuse. This low impedance path helps to ensure that a fault is quickly cleared, minimizing the risk of electric shock and fire. The size of the bonding conductor is determined by the size of the circuit conductors supplying the equipment. In general, the bonding conductor must be sized no smaller than the circuit conductors. However, there are some exceptions to this rule. For example, for motor circuits, the bonding conductor is sized based on the motor's horsepower rating. The National Electrical Code provides specific tables and guidelines for sizing bonding conductors for various types of equipment and installations. It's always best to consult the National Electrical Code and local electrical codes to ensure that the bonding conductors are properly sized. In the specific case of hydromassage tubs, the National Electrical Code addresses the bonding requirements in Article 680. Specifically, Section 680.74 covers the bonding of electrical equipment and metal parts in and around the tub. The general requirements outlined in Section 250.104 regarding bonding metal parts apply here as well. These sections mandate that all metal parts, including the motor housing, pump body, and any metal fittings, must be bonded together and connected to the grounding system. This bonding ensures that all metal parts are at the same electrical potential, minimizing the risk of electric shock. The size of the bonding conductor for hydromassage tubs is typically determined by the size of the circuit conductor supplying the tub's motor. As mentioned earlier, a number 10 AWG copper conductor is generally sufficient for bonding the exposed metal parts of the motor. However, it's crucial to consult the National Electrical Code and local electrical codes to verify the specific requirements in a particular jurisdiction. Some local codes may have more stringent requirements than the National Electrical Code. In addition to the bonding conductor, it's also important to ensure that the hydromassage tub is properly grounded. Grounding provides a path for fault current to flow back to the source in the event of a ground fault, tripping the circuit breaker or fuse and de-energizing the circuit. The grounding conductor is typically connected to the equipment grounding terminal in the circuit breaker panel and then to a grounding electrode, such as a ground rod or a metal water pipe. Proper grounding and bonding are essential for ensuring the safety of hydromassage tub users and preventing electric shock hazards. When dealing with electrical installations, it's always best to consult with a qualified electrician who is familiar with the National Electrical Code and local electrical codes. A qualified electrician can assess the specific requirements of the installation and ensure that it is done safely and in compliance with all applicable codes and regulations. Furthermore, it is also good to note that the term potential difference in electrical systems refers to the voltage between 2 points. The purpose of bonding is not to address a potential difference in the way the question describes. Rather, bonding aims to minimize voltage differences between metallic parts that could become energized due to a fault. By connecting all metallic parts to the grounding system, bonding ensures that if a fault occurs, the fault current can flow back to the source, tripping the overcurrent protective device into energizing the circuit. The idea that a number 8 solid wire is necessary to handle some kind of potential difference is a misunderstanding of the purpose of bonding. The appropriate size for the bonding conductor is determined by the National Electrical Code and is based on the size of the circuit conductors or the horsepower rating of the motor, not on some perceived potential difference. The inspector's insistence on a number 8 conductor may stem from a misunderstanding of the National Electrical Code requirements or a local amendment to the National Electrical Code. It is always best to consult the National Electrical Code directly and to clarify any local requirements with the local electrical authority. It's also worth noting that the National Electrical Code is updated every 3 years, so it's important to ensure that you are using the most current version of the National Electrical Code. The National Electrical Code is a comprehensive set of standards for electrical installations, and it covers a wide range of topics, including grounding and bonding. The National Electrical Code is developed by the National Fire Protection Association (NFPA), and it is widely adopted by states and local jurisdictions in the United States. The National Electrical Code is not law, but it is often adopted into law by state and local governments. When the National Electrical Code is adopted into law, it becomes a legal requirement to comply with its provisions. In addition to the National Electrical Code, there may also be local electrical codes that are specific to a particular city or county. These local codes may be more stringent than the National Electrical Code, and it is important to comply with both the National Electrical Code and the local electrical codes. When working on electrical installations, it is important to be aware of the applicable codes and regulations and to follow them carefully. Failure to comply with the codes and regulations can result in fines, penalties, and even criminal charges. It can also create a safety hazard that could lead to injury or death. If you are not familiar with the National Electrical Code and local electrical codes, it is best to consult with a qualified electrician who is familiar with these codes. A qualified electrician can ensure that the electrical installation is done safely and in compliance with all applicable codes and regulations. In summary, the local inspector's requirement for a number 8 conductor for bonding hydromassage tub motors is not supported by the National Electrical Code. A number 10 AWG copper conductor is generally sufficient for bonding the exposed metal parts of the motor. It is important to consult the National Electrical Code and local electrical codes to verify the specific requirements in a particular jurisdiction. Proper grounding and bonding are essential for ensuring the safety of hydromassage tub users and preventing electric shock hazards. Always consult with a qualified electrician when working on electrical installations. To reiterate the crucial points, firstly, the National Electrical Code Section 250.104 generally calls for a number 10 AWG copper conductor for bonding exposed metal parts. Secondly, the branch circuit conductor size, such as number 12 AWG, is determined by the load and overcurrent protection, not the bonding requirement. Thirdly, the bonding screw on the motor is for ensuring all metal parts are at the same electrical potential to prevent shock. Fourthly, the bonding conductor's job is to provide a low resistance path for fault currents, not to carry significant current under normal conditions. Fifthly, using an unnecessarily large conductor like number 8 can create practical problems with bending and termination. Remember to always consult the latest edition of the National Electrical Code and any relevant local amendments. When in doubt, seek guidance from a licensed and qualified electrician to ensure compliance with all applicable regulations. And always prioritize safety when working with electrical systems. Electrical work should only be performed by qualified individuals who are trained and experienced in working with electricity. If you are not qualified to perform electrical work, it is best to hire a qualified electrician to do the work for you. Working with electricity can be dangerous, and it is important to take precautions to avoid electric shock. Always turn off the power before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment such as rubber gloves and safety glasses. If you are not sure how to do something, ask a qualified electrician for help. Electricity is a powerful force, and it should be treated with respect. By following these safety tips, you can help to prevent electric shock and other electrical hazards. Furthermore, understanding the principles behind electrical safety is crucial. Bonding and grounding work together to protect people from electrical shock. Grounding provides a path for fault current to flow back to the source, while bonding ensures that all metal parts are at the same electrical potential. When a fault occurs, the fault current flows through the grounding conductor back to the source, tripping the circuit breaker or fuse and energizing the circuit. This prevents the metal parts from becoming energized and creating a shock hazard. In addition to bonding and grounding, there are other safety measures that can be taken to protect people from electrical shock. These include using ground fault circuit interrupters, or GFCIs, which are designed to detect small amounts of current leakage and trip the circuit breaker before a person can be shocked. Ground fault circuit interrupters are required in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor areas. Another safety measure is to use double insulated tools and equipment. Double insulated tools and equipment have an extra layer of insulation that protects the user from electric shock. Double insulated tools and equipment are often used in areas where there is no grounding system available. By taking these safety measures, you can help to protect yourself and others from electrical shock. Finally, remember that electrical codes and regulations are constantly evolving, so it is important to stay up to date on the latest changes. You can stay up to date by attending electrical training courses, reading electrical trade magazines, and consulting with qualified electricians. By staying informed, you can ensure that you are following the latest codes and regulations and that you are providing a safe electrical installation. Understanding the rationale behind electrical codes and practices such as bonding and grounding is essential for ensuring safety and preventing electrical hazards. It is more than just following rules. It is about understanding the underlying principles that protect people from electric shock and fire. Electrical safety is a shared responsibility, and everyone has a role to play in ensuring that electrical systems are safe and reliable.